Welcome, Algebra 2 students. We're going to talk today about how to graph a parabola. But there are some things we need to go over first. So first, every parabola has an axis of symmetry on the x-axis. And what that means, I'm going to give you an illustration here so you can see that. Here is a coordinate plane, just a quick version. And this is a parabola. I'm just going to draw you a quick one like that. Let's pretend this is a little bit more symmetrical. Every one of these parabolas is going to have an axis of symmetry. And an axis of symmetry is going to be the line about which this parabola is going to rotate. So what that means, all right, that's a little bit more centered. What that means is that every point on this side is going to be reflected on this side, and the vertex of the parabola is going to be centered on your axis of symmetry. So the x value of your vertex is where the axis of symmetry is located. So that's another thing that you're going to want to make a note of, is that the x value of the vertex, I can actually spell these without running them together. The x value of the vertex is the axis of symmetry. All right, so make a little note of that and make that illustration that this is the axis of symmetry, and this is the point at which these two sides of the parabola meet, and it is going to be on the axis of symmetry. So that is the vertex. So it's the very bottommost point, and the point at which these two sides start to ascend or descend. All right, number 2, I'll write that here. Every parabola opens upward or downward. And it's really easy to tell whether it's upward or downward by looking at the equation, because the x squared value is going to be either positive or negative. So if it's positive, this is positive. If it's a positive parabola or a positive equation, it's going to open up. And if you think about it, this is the axis of symmetry is on the x-axis. So it's going to be parallel to the, or horizontal, like the y-axis. And with the y-axis, up is positive and down is negative. So it makes sense that the parabola would open in the direction that follows those signs. So negative is going to open downward. So be sure to put those in your notes. So if I have a parabola that opens downward like that, it means that the x squared value is going to be negative. So the negative x squared, this would be a positive x squared. Okay. Number 3, the parabola crosses the y-axis at the value of the constant. So the parabola crosses at the value of the constant. I should say the y-axis, The parabola crosses the y-axis at the value of the constant. Remember, in a linear equation, we have y equals mx plus b, and that plus b is where it crosses the y-axis. The same is going to be true for your parabola. Your parabola is going to be y equals x squared plus x plus b. This plus b is going to be where it crosses the y-axis also. And this is the standard formula for a parabola. All right, you're going to take down all of these notes. If you need to pause the video to do so, this is going to be extremely important in doing the next bit. The next part, we're going to actually graph some parabolas. So I'm going to scroll down to the graph paper here, and let's look at one of these. All right, so our first practice problem or example problem is 100.1. Complete the square to graph y equals x squared minus 4x plus 2. So that's what we're going to do. We're going to, first of all, look at the original equation, and we see here the constant. So this is going to be our y-intercept. So this is what we will graph, 0, 2. We'll graph that, and that's going to be where the parabola crosses the y-axis. We'll go ahead and graph that point to start with. That's our first point. Now we need to find the vertex of the parabola. That's going to help us find the second point. So we're going to complete the square in order to do that. But because we already have the equation here, y equals, we don't want to disrupt that. We want to keep that constant. So what we're going to do is we're going to separate the part that we would normally use to complete the square with parenthesis and leave some room in our equation to add the part that we need. So that would be y equals, we're going to make a parenthesis here, minus 4x here. Leave a little space, put in our other parenthesis. That's going to be allowing for our third term, and we're just going to move that plus 2 to the end. Now, whenever we would do this around an equation, around an equal sign, whatever we would add here, we would add here. But we don't have an equal sign to move about or to add to both sides to keep it balanced. So in order to keep this balanced, whatever we add to it, we're going to have to subtract from it as well. I know that's a little, like it seems like that is pointless. You're going to add the number and subtract the number too, but we're going to add the number to the part that we are completing the square with, and we're subtracting it to keep it balanced, to keep the statement true. You have to do that, but that allows us to factor this as a perfect square, but we can combine it with our other term, which is what we would normally do on the other side of the equation, and it still gives us an accuracy there because we are keeping the y statement balanced. So we're going to do that now. And we know how to complete the square. We take the middle term, which is negative 4. We divide it by 2, which equals negative 2. And then we take that number and square it. And that is going to be the number we add here. But because we've added it, we also need to subtract it to keep this equal. We've got to keep it equal and balanced. So this allows us to do so. Now we're going to factor. And when we factor this, we're going to find we always use this number that we squared. So it's going to be x and then the number that you squared, square it. And then we can combine these. So it's going to be a minus 2. Now, this is a positive x, right? So our parabola is going to open up because it's a positive. And that is what tells us that. Now, this number here is going to tell us the vertex x value, but it's going to be the opposite. This is our AOS, or our axis of symmetry, and it's going to be times negative 1. It's always the opposite of this number. So x is going to be equal to a positive 2. All right. So that tells us the axis of symmetry. So we can go ahead and put our axis of symmetry, and we can just put in a little dot right here. We know that that is the point at which the parabola revolves around. Now this number tells us the y value of the vertex. And because we know that the axis of symmetry is the x value of the vertex, our point is 2, negative 2 for the vertex. So we can plot that. So 2, negative 2 is our vertex. Now to plot our third point, what we do is we go back up to the y-intercept and we look at it and we say, we know that this is the point at which the other side is going to be mirrored against. So whatever is on this side has to be a reflection of this side. So if this line here is 1, 2 from the axis of symmetry, the corresponding point is going to be 1, 2 from the axis of symmetry on the other side. So now we have two symmetrical points in our vertex, and this is going to allow us to draw our parabola. And so all we have to do is draw an arc or a U shape through these points. And I can do this probably a little bit easier than you guys on the system because I can manipulate these after I've drawn them. I am concerned about the points, and I'm concerned about you trying to get that U shape close. But I don't expect perfections. And you can see here that when I've drawn this, I have kept it in that same kind of strand. So 1, 2, 3, 4, and it's over 2. 1, 2, 3, 4. This should actually be over 2, I think. Let's try that over here. No, that's not going to work, not for this shape. So it's going to have a decreasing ratio. So the most important thing is we get that vertex and those 2 points covered, and then try to make sure that these points here are equidistant from the axis of symmetry. So wherever you stop, just make it equidistant from the axis of symmetry. So 1, 2, 3, 1, 2, 3, and it's including this point, and this point. That's the most important part when drawing your parabola, okay? It has to be equidistant all the way down, and it has to cover these points here. And that's going to give you your a good parabola when you follow those points. So let's do the next one. Pause and write all this down if you need to. All right, so 100.2, complete the square to graph y equals negative x squared plus 2x plus 2. So right away we see that we have a negative x squared value, so this is going to open downward. And we see that we have our first point, our y-intercept. So that y-intercept is going to equal 0, positive 2. So we'll find 0, positive 2. Let me graph that here. There's our y-intercept. So now we're going to complete the square to find the rest of it. So let's, I'm just going to switch over to the white marker. We'll just keep this the same. Now it's a little different. When you have that negative x, we do not like that. We just don't like that on our part that we have to complete the square on. So what we're going to do first, let me write this out. We are going to multiply this by a -1, and that's going to change it just a little bit. We're going to have a negative y equals a positive x squared minus 2x minus 2. Now what that does is it transfers that negative sign over here while we are factoring. It just helps us factor a little bit. And then don't worry about it because we will put it back before we graph our parabola. And before we find all our points. It's just going to help us through some of it. So now our next step is going to be to factor the completing the square part. So let's do this to write it out, allow ourselves some room, -2. So now we can complete the square in here and find this number. And I'm going to do that right over here to the side. I'm going to say -2 divided by 2, that equals -1. Square that, we have a +1. So +1 here, and to keep it balanced, we subtract 1 over here. So now I'm going to factor this, and we know all we have to do is say x and take the number that's here that we squared, -1 squared, and we combine these, it's going to be -3. Now we're going to go ahead and get rid of the negative sign on the y by multiplying again everything times -1. So y is equal to negative x minus 1 squared plus 3. This is how we will graph it. So now we take this sign, tells us that it's going to open downward, right? It's a down. This is our AOS times -1. So x is equal to +1 because negative negative is a positive. And then this is going to be our vertex y value. So our vertex is going to equal 1 and 3. So our axis of symmetry is at 1. So we would put the little axis of symmetry right there, just so we can kind of have that reference when we draw. And then we're going to take our vertex and we're going to put it at 1 and 3, which is here. And now we're going to look at our y-intercept and we're going to mirror that on the other side, which would be right here. Okay, now we're going to, I'm just going to take the green just so you can see it. And I'm going to draw the parabola. And I'm just going to go through these points. There we go. And I'm just going to adjust that a little bit. I'm going to move it up. Get these in the right spot where they cross those lines. And there we go. That's my parabola. Trying to get these equidistant, so they're about 2 and they're about 2 from either side, so that's close. And that's what you kind of want to do. You just want to do this side, do it around to where it's about equidistant from the axis of symmetry, and it hits those 3 points. So you have an understanding of what it's supposed to do and where it's supposed to be. I am going to be checking for the 3 points and whether or not these are kind of equidistant from each other from the axis of symmetry, just to make sure that you understand the axis of symmetry and how to find those points. And this is going to ensure that you know it's supposed to be a reflection. So let's try one more. All right, in completing the square, to graph this, we're going to do some other steps first. And the first step is to find the y-intercept. And the y-intercept is going to be 0, -8. So that's our first point. So let me make sure I've got this long enough. 1, 2, 3, 4, 5, 6, 7, 8. Just barely long enough. Let me elongate this just a touch so we can make sure we get all the graph that we need. There we go. That should help a lot. All right, so now we're going to complete the square to find the rest of the parts. So y equals -x squared minus 6x minus 8. So our first step, because we have a -x squared value, is we're going to multiply by -1 the whole equation. Negative y is equal to x squared plus 6x plus 8. Now we're going to allow room to complete the square. X squared plus 6x. We leave a little space and then we say plus 8. So we take this positive 6, we divide it by 2, that equals 3. Square that, that's going to be 9. So we're going to add 9 and then subtract 9 so we can keep that equation balanced. And then we're going to factor. Negative y is equal to x, and we take this number here, which is a positive 3, and we square it, and we combine these two. That's going to be a -1. Now we take our -1 and multiply so we can get rid of the negative sign on our y. Y is equal to negative x plus 3 squared plus 1. So now we know that the parabola is going to open downward. We know that our AOS, or axis of symmetry, times -1 is going to be a -3. So we can go ahead, 1, 2, 3. We can do this right here. There's our axis of symmetry. And our point is going to be, here's our y value. So our vertex is going to be -3, +1. And we're going to plot that here, right here. -3, +1. So there's our vertex. Here's our y-intercept. So now we're going to come across 1, 2, 3, 1, 2, 3. And there is our mirrored point from the y-intercept. And now all we need to do is draw our parabola. I'm going to see if I can get really close. There we go. It always gets smaller, so I'm trying to draw it a little bit bigger so it'll jump down to the right spot. Put that on that point. I'm going to, this is actually long enough. I'm going to just try to hit it right about there and hit it right about there. That's pretty equidistant on both sides. And it hits both points, so that looks good to me. All right, so I've hit all 3 points. These on the end are equidistant from the axis of symmetry, so that looks like a good parabola. And again, I didn't mention it, but this would open down because it is negative, which once you get your vertex and your y-intercept, it's pretty obvious the direction that it opens down. This is just a check for you to make sure, yeah, it's negative. It opened down, so good, I did that right. Okay? So just use it as like a reference to make sure you're doing it the right way, because your points are going to tell you which way the parabola opens if you do them the right way. So do them the right way. All right, that is all we have for lesson 100 in graphing parabolas. I hope that helps you see everything that you need in order to do that. If you have any questions, let me know, and I'll see you in lesson 101.